Hi, in this video, let's just look at the noise in the inverting amplifier configuration. And what I've done here is this noise source is the op-amp noise source, and this noise is associated with R1, and this noise is associated with R2. Okay, there is an input of Vin, which let's assume does not have any noise, and we are looking at output. And what we want to find out is what is the noise at the output? And how is it related to mean? Okay, so one of the easiest ways of looking at problems like this is to use what we've talked about before in the previous courses, uh, something called superposition. Remember that? Okay, what is superposition? Superposition basically refers to so how many sources are there in this particular circuit? There is this Vin, that's one source. Then you have E1, En, E2. So there are four sources. And what we do with these four sources is we take the output of the system because of each one of these sources separately, and then if we assume that the system is linear, we can add up the outputs, all the four outputs, and then we can figure out what the circuit behaves like. Okay, so let's assume that this voltage source, okay, this voltage source is 0, this voltage source E2 is 0, and En is 0, and we are looking at V out because of V in. So we are looking at V out because of V in. And what is that going to be? Fairly straightforward, right? It's going to be minus R2 over R1 V in. So we've got that. Now let's try to evaluate V out because of E in, okay, which is basically this source. So in that case, what we want to do is uh, we want to make the source that is here V in into a 0. And if it is 0, basically what we are saying is this is connected to ground. Okay, and of course E1 is not there, E2 is not there, only En is there. So then what does the output become? You can easily see that if you are only considering En and you're switching off E1, E2 and you're grounding this, that becomes a non-inverting configuration. So what you get is 1, let me write it with the black ink. So 1 plus R2 over R1 En. So that's the noise at the output because of En. Now let's calculate the noise V out because of E1. Okay, in this case, what are we going to do? We are going to make En equal to 0, not consider it. And of course, we are considering only E1. Okay, so what's the noise in that case? In that case, E1 behaves like a source, and basically you have the same gain as minus R2 over R1, right? So I can write the noise, the voltage output as minus R2 over R1 E1. Okay. Now the last thing that we want to do is we want to do V naught, V output because of E2. And so what we want to do is we want to cancel this source, and we don't want to cancel this one, so let's remove that. And now let's calculate the the voltage output because of E2. So that's probably a little complicated, right? So let's take a look. So the voltage at this point is 0. The voltage at this point is also 0. Okay, basically because, well, this is connected to this point and the voltage En is 0, so that's connected to ground. So that's 0. So this is 0 volts. We know that this is V output. So let's write the equations corresponding. Now what's the current then? So the current that is flowing through R1 has to be 0, right? This current has to be 0. And this current of course is 0. So this current is going to be 0. So basically what is going to happen is if this current is 0, there is going to be no voltage drop across R2. then the voltage from here is E2, and that E2 is equal to V0. So this is going to be E2. Okay, so now we have got all this. So what is the total output going to be? Now, the problem with calculating the total output is going to be that you will have to have all of these as RMS voltages. Okay, so the better way to do it would be to calculate V output because of noise, or the noise at V output, and that's going to be this square plus this square plus this square, right? So it's going to be square root of VO En square plus VO E1 square plus VO E2 square. So that's going to be the noise, the RMS voltage of the noise, and we know the output because of the signal, and you can easily calculate the SNR from here. Hope that gives you a certain idea of how you analyze op-amp circuits in this case.